Hello, welcome back to the Oxford Online Maths Club. My name's James, and this week I'm joined by Elwyn.
Hello, I'm a first year at New College doing maths.
New
Obviously.
College, it's my favourite college, of course. It's a college where I do some teaching. Hooray! Um, also joining us live is some of you, because we have Slido underneath, which is where you can say hello, like the user Lala has just said hi. Let's set that so that Lala is at the top. There we go. Lala goes to the top. You can jump in and say hi if you like. That's where you're watching from. Plan today, when I let you start, is juggling mathematics. We've put juggling by numbers as the title on YouTube. I want to start by saying hi to chat. So I'll just give chat a moment to get together and check that we've set up the live stream correctly. I think I have. Oh gosh, I never really know. Looking over this way, I'll try doing the poll and seeing how that's going. We have this poll where they can tell us how their day's going on a scale from 1 to 5. It says, how was your day today? And one person is in chat and says they're having a 5-star day. Elwyn, how's your day going on a scale from 1 to 5?
I'd say about 4.5.
4.5's pretty good. Not an option
Yeah,
in my
it's
poll, which is kind
it's
of.
been quite a chill day. I've just done some work and just handed it in. Hope that it's good.
Ah,
That's
which
it.
work? What? Whose deadline is? Sorry, which work are you doing? What's due on
Algebra
Thursday?
and linear algebra.
Ah, right, the kind of pure maths sort of
That's it.
sort of stuff. Yeah, okay, it's not
Yeah,
not the applied math side of
not
things.
yet.
That's my hand in at the weekends. Great. Okay. Hello to Mary in chat as well. So far, chat's having an incredible. This is the best we've really had. We've got not very many people in chat immediately, but the ones who are there are having a wonderful time. So it's pretty good news. Somebody called Euler's character has just joined, which reminds me that you can set your username to be anything you like, uh, including your favourite bit of mathematics if you like. Euler's character is from last week when we had topology and shapes and things. And they say, "How's my day going on a scale from 1 to 5?" Thank you for asking. I think I'm having a 4-star day. You said 4.5, right?
Yeah.
I think I'm a 4-star day. I don't know.
Hmm.
Seems about right. Space to improve with juggling. On screen at the moment, just want to advertise quickly the concept of further reading notes. On either Friday or Monday after the live stream, we put up some further reading notes on the Maths Club website. So if you found us on YouTube, we also have a website where we post links to previous episodes. They're in a playlist here as well. Further reading notes, which look roughly like this, with links to other stuff like videos or further reading, things to watch. And I just want to repeat this because I think not everyone was here last week, but we have Promise Europe is a summer school in the summer. If that sounds like something you're looking for because you want to do lots of maths over the summer, maybe Promise is a way to do that for people in Europe, although there's also one in Boston and one in Italy. Don't ask me how that works with Italy and Europe both being versions of Promise, but the Promise Italia is also a thing. Good, cool, okay. I think we're live. I think it's happening. I'm going to turn off the poll. I think it might be time for juggling. Yeah, I think so. So, enough waffle from me. Oh, mailing list. Yeah, they know what the mailing list. Enough waffle from me. I think it's time for juggling. Over to you, Elwyn.
Hello. So, I'm pretty good at juggling. But I'll go. But can you guys hear me over here?
I can still hear you, which I think means
That's
stream can hear
good.
you. Shall I put you on the big screen? I have these like
Sure,
juggling
yeah.
balls. Yeah, okay, okay.
As
This
well.
is not super elegant. We're going to do that, and then that, and then that. It's my method to get you on the large screen.
Nice.
Okay, show us some juggling, Owen.
This is the classic cascade pattern.
I think we're broadcasting it okay. Got 3
This
balls.
is the classic standard juggling, three balls.
Pretty
That's
impressive.
it. And what's interesting is that there's a bunch of you can vary a lot. So you can do this sort of thing, and you can do this sort of thing, and you can do this sort of thing.
Is that behind your back?
Yep, there you go. But like they're all actually the same pattern because if you if you think about it, this is very similar to this. The balls are just going, they've got different trajectories, but they're doing the same thing essentially. Whereas you can do a bunch of other stuff like this, or you can do this, or you can do this. And those are actually distinct because you can see in that one, there's a big throw and a small throw. Whereas in this one, they're all at the same height. There's a constant like frequency, really.
I think I can hear the difference as well. So we're getting your audio
Yeah,
through as
yeah.
well.
I
I
really
can
like that
hear
as
the
well. Sometimes
difference.
I juggle to music and find the nice patterns that go along with the music.
Nice. Get. Oop. Gonna switch you back because you. Oh, yeah, I know how to do that. There we go. Ah, perfect. Seamless transition. What?
Yeah. So
Technology. I can make our win on the small square or on the big screen. Did I remember to press all the buttons? I hope I remember to press all the buttons. Maybe you were tiny for that whole thing. The rhythm is different, right? So some of those juggling patterns, even like the sort of backwards one and the behind your back one, the pattern is still the same. You got
yeah.
the same pattern all the way through, but then there's some sort of fast juggling where you're doing like genuinely different sorts of throws. Juggling.
Yeah, and what we'd ideally want is some sort of way to tell if two patterns are actually different or if they're actually the same, because it's not always easy to tell.
Yeah. So like I guess if the rhythm is different, then there's something they can kind of hear
Yeah.
or something going on there.
Yeah. So I think the easiest way to think about it is to just only think about the moments when a ball is caught or thrown, because everything else in between doesn't actually matter for the pattern to be the same pattern.
I see. Okay, so modulate the like small business of the ball arriving in the right place at the right time via
Hmm.
all of the sort of mathematician reduction of the problem, right? Because mathematicians love reducing problems down to the kind of elemental
Yeah.
parts, right? So you're forgetting all of this business about it flying through the air and having to go to the right place at the right time, and getting the throw right. The moment that you throw it is the thing that you're talking about. Um,
Yeah.
okay, tell
And
me more.
catching it.
And then catching it, right? Okay. The small business of when do those things happen? Okay.
So you can essentially like take your time interval and just cut it into chunks that actually those are the actual bits that matter.
I've got these are supposed to be juggling balls on the screen.
Hmm.
I suppose there's sort of a time. There's a moment that you throw this one. We could do how to juggle
Yeah.
for beginners, right? You throw the green one, and then there's an event that you throw the red one. This is kind of the crucial thing about juggling. I mean, your next step could be to just catch the green one, in which case you've stopped. You need to keep it going. The next move is to throw the red one, and then event catch the green one.
Hmm.
The red one's flying through the air. Guess we're not really thinking about that. Throw the yellow one, catch the red one, and then keep going.
Yeah.
By induction, you can now juggle forever.
You could, there's a thing called a ladder diagram, which helps to draw this out. And I think these balls we have on the screen could help a lot with this. I'm going to try and draw a ladder diagram. So it's
I
called a
think
ladder
I
diagram
think I've
because you've
seen
got
one of these. Yeah, yeah.
these two things here. And we're going to imagine that our time starts here. This is like t equals 0. And our time is going down like this.
Time vertically downwards. Okay, okay.
Yeah. I mean, it could be going upwards. It
Well,
doesn't really matter.
yeah, fair enough. Time
If you
vertically downwards. We'll
Yeah,
roll
if
with
you
it.
played a video of me juggling in reverse, it would still be the same pattern, I think.
I think the
Maybe
throws.
at least for the classic cascade, it will be. For others, I'm not entirely sure, but I think it would be.
I think you're rotating your hands like this. I think. So then,
Hmm.
if I reverse it, everyone at
But
home is
that,
also, I imagine, spinning hands in
yeah,
opposite directions. But then, if you reverse it, your hands are going the other way. But I suppose all the events, if you're just tracking when stuff happens, that pattern's kind of the same
that would be
on
the same.
the same
Yeah.
sort of events. Okay,
So
so
you could imagine having some kind of ball here and then saying this is going to be my t equals 1. Um, and ooh,
yeah.
let's say t equals
Well, so let's do one, two,
uh,
three for the different throws, I guess, or zero,
yeah,
one, two for 0, 1, 2. You got to throw, throw, throw.
yeah,
So time 0, time to start juggling. I think we throw the red ball. I'm going to colour this ball red.
So in the classic three ball cascade, you can't throw it and catch it on t=1 because if you if you just look at it,
Oh, that's all right. That's more screen.
there's things happening. Um, there's things happening in between the time one ball is thrown and caught.
Yeah, I guess if this ball is thrown at time 0, it's not its turn to be thrown again until. Well, they're sort of taking it in
Exactly.
turns, aren't they? With all
Yeah.
things being
Yeah.
equal. So there's a red ball being thrown, and then I guess we're going to throw the green one and then the yellow one, and then get back to the red one again. So it's not going to be thrown until it gets down to about time 3.
Yeah, I think that's right.
Here. So because there's 3 of them, and they're taking it in turns. If our time is counting throws, then every third throw is one of the red ones, which means that from this hand on the left over there, it's got to stay in the air, crossing over until it gets to your hand here, and then sort of hangs around there a tiny bit, I suppose, while you're holding it. Then it's time to throw it again, I think. I think that's what Rebel's doing. So this is kind of weird chart which shows its progress left to right over time. So this line means as time goes up, reading down the page, large times it's going left to right, I think. It's not showing the height, which is kind of a crucial thing about juggling. I think, that the balls are going up and down.
Yeah, the height doesn't really matter if we're just thinking about the pattern of it.
Okay. So ball going left to right. I think if you ask people to describe juggling, they might not describe it as balls going left to right, but here we are. Okay, so in between, before all of the rest of this happens, I guess the green ball, we've got to throw that one. I guess we're calling that. What are we calling that time?
I think that's time 1.
Yeah, it feels like that's our rhythm. I think time 0 is when to throw the red ball, and then time 1 is when to throw the green ball. And if the red ball is doing multiples of 3, then I think the green ball might be doing one more than the multiples of 3. I don't really have a formula for that.
Yeah.
So I think I need time 4 on this picture. Oh, not down there. Whoop. Time 4, nice. Okay, time to throw again. So there's that thing going on. And what do I want? I want the yellow ball. So, okay, acting it out. Time 1, you throw the green ball. And then you catch the red ball at some point. I'm not really sure I'm not really sure what happens next. We'll think about that in a second. Green ball's flying through the air. Time 2, it's time to throw the yellow ball. And now we find out whether I can reliably draw yellow. Does that show up at all? Not sure. This one. Time to throw this one. To 5. Ready to be thrown again at time 5. Okay. So I've got things alternating hands as I go down. I've got blobs for throws. Okay. Blobs for throws. I've got things alternating hands. How do I keep continuing this? Do I keep going?
I mean, you could keep going forever.
Oh yeah, we said you could keep juggling forever, right? So this needs to land just in time to be thrown at 6. And then it will come over here just in time to be thrown at 9. Whereas the yellow one is thrown at 2 and 5 and 8. And the green one is thrown at 1 and 4 and 7. So I'm trying to do that at time 7 down there. And you get this rather nice sort of braid forming in the picture, right? Things crossing backwards and forwards.
Yeah.
Cool.
This diagram is good at showing where the balls are and when they are, but it's a bit big. Like if you wanted to actually categorize different patterns, you don't want to be drawing out a diagram every time. So you kind of want to compress this diagram down in some way. And the only real important part of this diagram is the fact that they're thrown at some time t, and they're caught at some time t+3, and they just keep doing that. So the three there is the amount of beats it takes for every ball to be caught after they're thrown.
Sure. So the red one's doing multiples of three, plus 3 each time. The yellow one is doing 2, then 5, then 7, and in each case it's sort of getting ready to be thrown again 3 beats later, because they're all taking it in turns.
Mm-hmm.
And talking about it like that, it seems a bit like that might be the only thing that's possible, right? The balls are being thrown, there are 3 of them, so well, it's got to be 3 beats until that ball's thrown again. So 3, 3, 3, 3, 3, 3, 3 for how many beats later until it's ready to be thrown again. And in chat, Rex asks, what if T is uneven? Which I suppose you can sort of distort it a little bit, I think.
Yeah.
If you throw something slightly higher, it will take slightly longer. This is generally considered an error because I think in juggling this throws off your rhythm.
I mean, you could do two throws and then one high one, and then 2 throws and then one high one, and that would still be a three. It would still be essentially the same pattern. It's just that we kind of we want our beats to be equally spaced because it's just nicer that way.
Yeah, in some sense you can you can distort the picture, so you can stretch it uh, by just making some of the juggling balls go higher. I think this is not that impressive to actually do in front of someone, but if you're juggling, then I find that it feels like a sort of sense of time slowing down or something, because you have this rhythm of juggling, and then if you throw a little bit higher, everything slows down. So the rhythm of what you were doing just gets slower. I tend to juggle extremely low, and which means I juggle extremely quickly, which is fine, except it's A, harder, and B, impossible to then collaborate with anyone else who's juggling because I'm juggling really fast. So for me, the juggling might look different, but same sort of diagram, just stretched and distorted. Mumble mumble topology, mumble mumble distortions, same basic structure. That's juggling. There you go. That's how to juggle. Keep throwing things so that 3 actions later they come back again.
Yeah.
There's another question in chat, which is that are there going to be TMUA live streams? Yes, good news. We've done Matt live stream for about 5 years. I think we did it 6 years in a row, and I don't want to stop. So even though there's no more Matt, I'm going to be running something called TMUA live stream, or something close to TMUA live stream, where we will learn about TMUA maths. That's going to happen on this YouTube channel, just like all of the other live streams we're doing. Right. Cool. Okay, we've got 3-ball juggling. Should we talk about? We could talk about other things. I mean, we could talk about 5-ball juggling, I suppose.
I can just about juggle 5 balls.
Yeah, same.
Just about.
Just about. Not sure I'm going to do it live. But also the maths of it, in terms of these patterns, I think people at home could probably guess roughly what that looks like. There's a version of this picture, but there are 5 balls. Throw them higher so that you can get more things done in between. But like juggling your work-life balance, right, to try and get other things done while some things are in progress and throw things up in the air. Yes. So to mix this up, I think we need to consider juggling tricks that you can create by throwing the balls not in turn one after each other, or not in this kind of regular +3 +3 +3 pattern. There's something for this called site swap that is a kind of mathematics notation for juggling rhythms. Do you want to say how that works? Or?
Yeah, so taking inspiration from this ladder diagram, when we said that the +3 is only real thing that matters, we can, in site swap, what you would do is you would represent that using numbers like 3, 3, 3, and so on. Because what that means is that the first ball is thrown 3 and it's caught 3 beats later. Next ball is thrown it's caught 3 beats later, and you just keep doing that forever. And it goes on forever, but so it's easier to just call that 3. This is just the 3 pattern. But you can do basically whatever you, well, not whatever you want. There are rules which dictate what numbers can or cannot go in a sequence. But one of them, for example, that 441, that's a very fun pattern. And what that means is that you throw a ball and it comes back 4 beats later. Then you throw the next ball and it comes back 4 beats later. You throw another one and it only comes back 1 beat later, which means essentially that you're throwing that ball again immediately.
Okay, let's try and draw a ladder diagram for 441. So this is a totally different pattern. And I suppose you mean when you write 441, oops, when you write 441, you mean 441, 441.
441.
So if there's a description of how to do a different juggling style, or different juggling rhythm or something, 441, 441 forever, which I was just running as 441. Let's draw a ladder diagram for it. I'm going to copy. What am I going to do? I'm going to copy this. See. Let's draw that one down here. That's a 3 juggling pattern. Let's modify this picture then. I'm going to get rid of all the arrows as well. Okay, let's see if we can draw it, and then see if we can juggle it. I think that's a sensible order, but let's find out. Do you want to describe what to actually do with... I'm trying to reset this. So it's kind of simple. So what do we do? So we throw the first one.
First one, you're throwing out of 4. So it's going to be thrown at t is 0 and come back at 4.
Throw it at t equals 0 and come back 4. So I guess it'll just go straight up, but I'm going to draw it... how am I going to draw this? Kind of like this, I suppose. Maybe it goes left a little bit.
Yeah, I've neglected to say that in the ladder diagram, these 2 sides represent the 2 different hands. And
the crossing.
Yeah, so t equals 4, not t equals 4, but a 4-beat throw would have to come back to the same hand because the beats alternate between the hands as well. And so an even throw has to come back to the same hand.
Right, I can't remember the word for this, but you're still doing a sort of juggling where you alternate actions with your 2 hands, right hand, left hand, right hand, left hand, which means that if you want to throw the red ball again 4 beats later, well, that's another right hand throw.
Yeah.
How did I start this last time? I think I started it this way around. No, probably this way around. Okay, so 4 means that one goes up in the air and it's gone quite high, because you have to throw it quite a bit higher in order for it to waste about 4 beats of time just in the air. Look at it go. Right, okay, it's up in the air. I like having these props on the board. It's much easier than the real world where gravity and the passage of time. Whereas here, you can throw that up there and it stays there. Anyway, okay, what next?
Then the next one, the yellow one, because it's in the other hand, is going to be thrown at 4 as well.
Okay.
So that's going to go up.
Like +4. So at time 1, there it goes. They've both gone. Okay, great.
And this one's going to come down at some point.
I think it's going to come down at time just before time 5. We're sort of saying in time for it to be thrown again at time 5. But that normally you don't have very much time with the ball actually in your hand. So the idea is that it's almost the same thing. Catch and then immediately throw it again, whatever's next on your plan. Okay, in between, so you've thrown the red ball, it's gone really high, it's disappeared off the top of the screen. You throw the yellow ball, get rid of that one as well.
Now the red one starts to come back down, so you've got to make space for it, basically. So this one's coming back down, so this one's got to go somewhere. The pattern says it's a 1, so that's just good. That's going to be really quick. So that's just going to come straight across here.
Okay. Have I got this right? I think I've got this right. So it's like +1 means that no, I'm not right. I'm doing 2 things at once. So at time 0, you throw the red ball. At time 1, you throw the yellow ball. At time 2, you throw the green ball.
Yeah. And
+1 means that you'll catch it in time to throw it again at time 3. So then the pattern, we've got to the end, so it says a repeating pattern, so then we do it again.
So
And
now you're actually starting with the opposite hand you started with the first time. It's quite interesting.
also, it's the green ball again.
Yeah.
So in normal juggling, the 3 colours of ball just take turns. Whereas in this pattern, not obvious from the 4-4-1 notation, but in this pattern, you throw red, then yellow, then green. But the green throw is like a very quick +1 throw. So it's time to throw the green ball again. And this time
That gets thrown at a 4.
Yeah, so it's going to
So
come
now
down.
it's coming out like this. The yellow one's probably come down at some point. Here we go.
I think
The red one's come down more. I think.
The remarkable thing, which is not at all obvious at the moment, is that this works. So you threw the red ball, the yellow ball, and then the grey ball will just change hands and throw it up in the air. And then all of that messing around done, the red ball now lands, and it's time to throw the red ball again. What happens next?
Next in the sequence is another 4. So this one's...
get rid of it again.
Yeah. Now the yellow ball comes back down.
Yes, at time 5. And is that a 1 next?
Yep, that's a 1. So that one comes right over here.
And then I see what happens next. Is a 4 next, isn't it?
Yeah.
Right. Okay. So that'll come back at like time 9 or something. So somehow this works out that there's always exactly 1 ball ready that's just landed, ready to be thrown again, and somehow it sort of works out. Do you want to demonstrate it looking back up here, looking at the balls? Do you want to demonstrate what's going on? Maybe call out the numbers as you're doing the throws.
With these?
Yes, it's time to throw the yellow ball height 4.
Yep. So that's going to go 4 up here.
And the red ball's going to land.
Yeah. And then I think we're on a 1 now. Or is it the green ball landing?
This is the danger of doing it on the board. I've lost track of where things are.
So have I. The last thing we did was...
Yeah, it's green next. It's green next.
The green next.
Possibly.
So green's definitely a 4.
I'm trying to do it on the desk to try and keep up. I may have misled you about where we were in the pattern.
Okay.
Then follow some hasty juggling to try and catch up. We can start again.
We can.
Start again and juggle 4-4-1.
Yeah, I could just do it in real life.
Just do it in real life. There you go. There's an offer. Whoomph. Whoomp. Double click and cut.
So it's going to be a lot faster than it was on the board. So it might not be immediately obvious that this is what I'm doing, but you can definitely see the straight up throws.
It's kind of box shaped, right? So the 4s are going straight up because they need to come back to the same hand. And there's some passes along the bottom, the 1s. Oh, that's really good. But it's not a single ball at the bottom that's always going backwards and forwards. That roll changes between the colours as well. There you go, nice kind of rectangular U shape. Brilliant stuff. Pop, 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 pop. Good stuff. So in chat, Cambridge applicant, excellent username. I like it when they choose something. That'll get people talking. Cambridge applicant says, is it not odd to call it T because it doesn't really represent time? That's a pretty abstract take, Cambridge applicant.
I mean, you could call it B for beats, I guess. That could work as well.
Yeah, there's a rhythm. Like if you turn your head sideways, it looks a little bit like sheet music. There's like this sequence that time is passing and stuff is happening. Performance, you can delay or you can extend, but I think if I look at sheet music left to right, I would say that's pretty much time. It's maybe beats of rhythm, really, or what is time anyway. But I sort of think that's the IRL demonstration was the best, says chat. After all of their sort of messing around, I still saw one. See, looking at the 4-4-1. No, I still can't. I'm getting so confused about when. And then 4. No.
No, I think it was yellow
I've confused
for.
myself.
Mm,
Let's get them in the same starting positions. Here we go again. 4. No. 4.
for
4. 1. And then 4. And it
and
goes over
four
here.
again. And then the red
I
one's
have to, the red one, I
four.
have to land the red one before the yellow one. I'm getting there.
Yeah.
4. And then the
Four.
yellow one goes
And
across
one.
and gets thrown.
And four.
And then this one goes back up again.
Yeah.
You pass this one across
Yeah.
and throw it.
And throw it.
And throw it. You keep that one in the air. Keep that one in the air and you pass this one and throw it. Keep that one in the air, pass this one and throw it. Keep that one in the air, pass this one and throw. I've got there. Okay.
Great.
4 for 1 on paper. Hooray.
Yeah.
So totally different juggling pattern. And not obvious to me at the moment why, how can we generate these? I'd like to invent more.
Yeah, the question is
What
like
rules does this
how
do?
if you have some numbers, how do you decide whether it's going to work or not?
Yeah.
Because it is quite easy to find sequences that don't work. Like if you have like a I think
5-4-3.
I think
Oh no, 4-3-2.
I was thinking of 5-1-3.
5-1-3. Yeah. All right. Okay.
So if you have 5-1-3, that's not going to work because you're going to have two balls being caught in the same hand at the same time, which you could do, but we want to keep things simple, so we're not going to allow that for now, at
Hang on. Let
least.
me just work. Let me just work that out. Sorry. So you
Yeah,
throw at times 0, 1, 2, and you catch at times so +5, +2. Oh, I see. It's the first and the last ones.
yeah,
So if you throw this one at time 0, you'll have to catch it at time 5. And if you throw this one at time 2, because it's 2 beats later in the pattern, then you have to catch that one at time 5 as well. And now you've got 2 of them. So that's a problem.
yeah, and that's the process that we've done here, where you add on the time you've thrown at to the beats to get its landing time. That's precisely the process you can do to work out if any given sequence of numbers is a valid site swap or not.
Right, okay, so rules then. What is this? So we've got okay, so you need the numbers one number at a time because you're throwing one thing at a time, but you're also trying to catch one thing at a time. Otherwise, you'll get confused because you've got 2 balls at once, and you're only throwing one at a time. So you need the catches, which is sort of the sequence plus time. Sort of these things are describing 0, 1, 2, 3. What's the time when I'm going to do these things? You need those to all be distinct as well. Will be different.
Mm-hmm.
In chat,
Yeah.
Matty says, and they said this a while ago actually, does the whole sequence of beats in total have to be a multiple of 3?
That's a good question. If you're using 3 balls, it does. If you're using like n balls, there has to be a multiple of n, which is not immediately obvious.
No. Yeah, I suppose the way to see that perhaps is something like. How do you do that? Is it like over a long period of time? You've done a lot of juggling. Everything's been thrown a lot. I don't really know. How does that work?
I mean, the way I think about it, although it's not very rigorous, is that you've got the total amount of the numbers that you're adding up. That's like the total amount of air time that the balls are getting overall. And so if you take the average of that, that has to be the number of balls because if you're adding airtime to one ball, you're kind of taking away airtime from another, if that makes sense.
Oh, right. Okay. So, on the one hand, if you just try and follow an individual ball, it might be just very complicated, like I saw when you were doing 4-4-1. Any individual color ball is moving all over the place. But overall, the average of the numbers sort of tells you what's going on average? No. Average air time is something like. Yeah, I do want a nice argument that sort of ends with, and therefore that's how many balls you've got in the air right now. How many balls are you
Yeah.
juggling right now? Oh, if you sum them, they're all. It's awkward that a ball can just. We have this +1, where the same ball is being thrown twice, but maybe that's right. Within like a stretch of juggling. Maybe that's okay. Yeah, okay. The average of the numbers in the pattern turns out to be the number of balls that you're juggling. But that's sort of necessary but not sufficient, because the average of these numbers is 3. But it doesn't work because the landing times coincide.
I should also say there are some numbers that probably don't work like you might think they would. For example, 0 and 2. Because 2, you might think it's like a smaller version of 4. You just throw it up. But in practice, because it comes back 2 beats later to the same hand, you can't do anything with that hand. You physically don't have enough beats to do anything with that hand while that ball's in the air. So you might as well just hold it for those 2 beats.
Yeah, I've experimented with both. This is the effect where you're alternating hands. So throwing something here where you intend to throw it 2 beats later, well, that's the next thing. Yeah, but 2 beats is if you're going right, left. 2 beats later will be just the next thing you do with the right hand. So there's no time in between for. You definitely don't want to catch another ball with your right hand in between, because how are you going to get rid of it in time to deal with this +2 operation that was going on?
Yeah. And 0 as well. 0 is just not holding a ball or not catching a ball, which I guess is quite intuitive.
0 is maybe the weirdest thing in the juggling pattern. Do you know any juggling rhythms that have 0 in them? The thing that someone told me once is that 0 means click your fingers.
Yeah.
And the thing, I think Colin Wright says this. It's something like 0 is something that you could have space for a juggling ball there that appears and immediately disappears at the same time. So you threw it, but it immediately had to land straight away, so it sort of cancels itself out. It's going and coming at the same time. And when you click, that's the vacuum closing in on itself at the same moment. In and out again. Negative numbers don't work, right?
No, I think you'd have to go back in time for that.
Negative numbers would mean throwing a juggling ball and catching it before you threw it. So
I guess it's a bit like what we were saying earlier with reversing a video. I Now I'm thinking if you just make everything in the pattern negative and maybe reverse the order or something, would that that seems like it would work.
Yeah, that sounds like a videotape of someone juggling backwards, which is less impressive than it sounds. Sort of, I have tried this. You video juggling, you play it backwards, kind of looks just like juggling. Physics is reversible on this scale. Good. I have a slightly mad way of thinking about these rules of juggling, which I think you can use to invent new juggling patterns or to find new things that satisfy that rule. I'm going to do it now, I think. The thing about adding time makes me think about like a diagonal lines on a chart. Let me show you what I mean. So if I put time on this axis, which is maybe the more normal place to find it, then you've got some events. I'm going to represent this with a sort of square grid where why am I drawing this square grid so very badly? Never mind, here we go. I've committed now. I'm sort of drawing my square grid like this. I have some regrets. In my mind, 3, 3, 3, 3, 3 is a kind of consistent thing. Over here I can do the kind of throws, and over here maybe the catches, because each one is kind of an event. There's a coordinate for when did you throw it and when are you planning to catch it, and you can show that on this chart. So at time 0, I've drawn this grid. I already regret it. It was seconds ago that I drew it, but here we are. So if you throw at time 0 and you intend to catch at time 3, then I'll colour in that square. That's sort of when you intend to catch it. I've got to draw more grid. I'm going to draw a grid like a normal person. There we go. There we go. I don't know why I didn't think of this faster. Sometimes I do something on the live stream and I just think, what on earth am I doing? What has possessed me to draw an entire square grid just by doing this repeatedly? Okay. So you have this kind of throws and catches. So very first throw for normal juggling, I'll drop something like this, and then the next one you're trying to throw, the rule is that you have to catch it at a different time from this. So you could throw it up here. You could catch it here. That's normal, and that's sort of a +3 situation, I think. And if you keep doing that forever, then you'll colour in squares like this. That's normal juggling. To always catch things 3 beats after you threw them. But this pattern, we can illustrate other juggling patterns on this kind of diagram. For example, 4-4-1 looks like this. You intend to throw something here and catch it 4 beats later, or throw something on beat 1 and catch on beat 5, and then cheeky, on throw 2, at time 2, you intend to throw something, catch it on beat 3, so it's down here. And then you're going to do that again. So beat 3, you're going to throw something at 7, and then I think your plan is 8 for your next catch, which is miles off the top of my picture. And then, beautifully, at time 5, you intend to throw something just quickly for a 1 beat throw, which puts it here. And then the rules for juggling are, you'll try to colour in squares so that you have exactly 1 in each column and exactly 1 in each row. Like a Latin square or like a Sudoku. Like if you take out all of the 3s from a Sudoku grid, you get a juggling pattern, because you have 1 thing in each row and 1 thing in each column. So you'll always have a throw, and it will show you when you're supposed to catch that. Cool. The only thing I don't get out of, if I just steal the numbers from a Sudoku, it's kind of pattern of overlapping things, is, well, depending on where I paste my Sudoku onto the page, I might need more juggling balls or fewer. If I paste it here, then it means 4-4-1. If I paste it up a bit, it means 5-5-2. 5-5-2 is a 4-ball pattern. So this is a way to take 1 square from each row and column. You have to do it sort of maybe in a pattern, maybe forever, but that gives you a juggling pattern. You can use that idea to generate new things, because you can sort of think about, well, if instead of starting with 4, I start with 5, what happens next? Let's give it a go. I think this is a bit mad. I don't think I've found this anywhere on the internet of like people describing this in terms of like Latin squares or 1 from each row, 1 from each column. I think this might be a sort of mad thing that I'm doing, but anyway, never mind.
I think it might also help to give some intuition about why the average is the number of balls. Because if you have something like on the average, then you could just have, that's just the average. But if you have something above it, then you have to have something below it as well. So it all has to even out.
Yeah, I was trying to think about this. So if I put those back, yes, in the pan. So in a little bit of this square, a little bit of this has to have something in each row and something in each column, which I think means you can then add up the numbers in the rows and the columns. Although with my patterns, it's slightly harder to tell how many juggling balls you actually have. Yes, I can. Okay. Okay, let's invent a different juggling pattern. I'm going to be ambitious. I'm going to throw something height 5. And then the rule is I've got to put one thing in each row and 1 thing in each column. By the way, negative numbers don't work, so you're not allowed to catch things before you throw them. So I think that bans all of these squares. By like causality, you're not allowed to catch things before you've thrown them. There's a bit of a limitation, but we'll be all right. It sort of forces you to keep moving up the page. That's why I need to get it drawn. If you have to catch and throw in each ball, time between the first catch and the last match is by n beats. Uh, hmm, something like this. So, question in chat about how many balls you've got. Would you catch more balls by varying the height? What is the relationship between height and time here? Do you know this? Or like a
Well,
dynamics
the
problem, right?
heights, more height is going to mean more beats, which is going to mean more balls, right?
Yeah. So there's a relationship with something like if you wanted to actually take more time going through the air, you've got to throw it faster, you've got to put more effort into it, and it's got to go higher just to waste more time flying through the air. It's maybe the wrong way to think about juggling, to say, this thing's wasting its time being in the sky. It needs it to come back so I can throw it again. Not the most natural way. What do I want to do? So I want to average to about 3. What could I do? I could come down like this. I could come down here somewhere. So I sort of want to do something maybe quite short, where if I do, let's find out, it's 5 and then, I don't want to do 0, 5 and then 1. Let's change power. I think that works. So new plan is I'm going to colour in squares like this for 5 plus 5 every other throw. And then I'm going to hope that these ones fill in the gaps. I think this works. Every other one of these. And this takes much longer to get round. 5 and go over here. And go over, and then I've got another square over here before I actually fill in the gaps. So to start off with, I've got missing catches, and that always happens when you get started. As you start juggling, you're currently holding all of them. They should be in the air, they should be in the sky, but you're holding all of them. So to start off with, you're sort of missing catches that have sort of already happened because you're holding all of the juggling balls. But then later on, I think I've now got 1 in each row and 1 in each column. So the next one could be over here. 7 and 1. So I think 5-1 without the 3 on the
5-1.
5-1.
Yeah. Would you like a demonstration of that?
Wouldn't mind. Could you do 5-1 if we're doing requests?
5-1.
We haven't scripted this. Just chosen a juggling style. Go for it. Well, that's kind of quite low. Okay, so there's 1. You can go the other direction as well. Oh, I don't have that. Why is there a different direction? I didn't see that coming. So I sort of see like the brilliant stuff. Thank you. So what's going on there?
That one's called. I think that one's called the shower pattern. Generally, because it kind of goes in a circle.
It looks, with the nicest will in the world, it looks like how clowns juggle in a cartoon.
Yeah,
like
that's often. I think that's the one that people often try and start juggling at the beginning, but it's much harder than the normal cascade.
Right, you have to throw each ball quite high so that you've got time to process the other 2. If you're catching left hand, you've got to sort of catch and pass, and that pass from your left hand to the right hand, which I think people tend to sort of naturally do because they want to throw with their right hand every time.
Yeah.
That pass, in the worldview of the left-right alternating hands juggler, is +1. It takes a time unit. You can kind of do it a little bit faster maybe, but it takes a time unit. It's a thing happening to move the juggling ball from your left hand back to your right hand, ready to throw again. You've got kind of this cannon going 5, 5, 5 on the screen. But in order to sort of reload, you have to do this kind of shuffling motion between, which takes time. So yeah, I think I've seen people learn to juggle as well, trying to do this. The thing super high. What else can we do?
I've remembered one that I can do with a 0 in it.
Okay.
Should we do that? I think this one's called the snake.
The snake. Yeah, I'll put you back on the big screen. Give me a second.
Yeah.
There we go.
So this one is a bit weird because normally I start throwing with this hand with 2, but this one I think I start with this.
Oh gosh.
So it's called the snake because they're kind of following each other.
That's really good.
And the site score for this is 55500, I
Let's draw
think.
it. Excellent stuff. Right, okay, I'm going to try and draw it on my diagram. So 5550.
55500, I think.
5500, yes, probably.
Yeah, that averages to the right thing.
Okay, let's give it a go. 555 says first three things you do are to get rid of all three juggling balls. No refunds. Did you do this? Oh, I think you started a little bit one beat out from what I've drawn. I think you started. We'll come back to it. And then take a break. So 0 on my diagram is just a sort of normal looking thing. It's down here. And then I want even more grid time. So it feels like every pattern we draw needs more grid to be drawn, which is unfortunate for me because I want to draw another bit. So then at time 5, juggling balls start landing again. Time to throw them again. Let's get rid of them at +5. So up here, 10. Won't be catching those till 10, 11, 12. And then it's time to take a couple of beats off. So I think 8 and then 9 over there or something. Not my best diagram. I maybe need a larger square grid, which bear with me, I'll draw a larger grid. Okay, this is the start of. I can sort of see an alternative pattern, right? So you're taking this diagonal line, 555, and the difference is that instead of catching stuff over here, there's a gap which you fill in with, in some sense, the ones all the way over there. The catches that you're doing are not over here. They're catches where much later you're going to skip a couple of catches. So the patterns you keep going is these kind of 3s on that diagonal with some gaps in between. What happens if you just juggle with these ones filled in as well?
That will be the 5-ball pattern 5.
Right. 55555 is 5-ball juggling. So along this diagonal there's like hard mode 5-ball juggling. And the way you practice that, I think, is to do stuff like this, right?
Yeah.
So these 3 snake, the snake following each other is 3 of the 5 juggling balls.
Yeah, and then you introduce a 4th one, you get 555 55550.
55550, because
so that's like 5-ball with 1 ball missing.
Right. I think you could take any juggling ball pattern and replace one of the balls with just 0s whenever you would throw it. Oh, but when are you
but
it?
you'd have to, like, if you took out one of them, you'd have to like figure out how that propagates through, I think.
Yeah.
So yeah.
Problematic. I started saying something, I sort of regret it. Is there an alternative where you... So you've got three together. But if I think about 5... So 5-ball juggling is just you keep doing 5555555 all the way through. Is there a version of this where you don't have 3 of them snaking following each other around? But they have, I don't know how this would... Thinking about this, like 5 diagonal.
I think so.
Maybe move one of them over? But not move this one over? So sort of punch some holes in the 5-ball pattern to make it more manageable. Maybe this is not juggleable, but I think this would be... So 55050. I think maybe that works.
I think so. I think I've done something like that before. I can give it a go. Like 5-5. Right. So it starts like 5-5.
I'm getting you to do 5-ball juggling, but delete 2 of the two non-consecutive balls.
There you go. Got it.
Okay.
Not very good.
It's less pleasing than the snake juggling somehow. It's like
5-ball
juggling, but 2 weird ones are missing. Cool. Right. Okay. Way to generate patterns by removing juggling balls from hypothetical 5-ball juggling.
You can also generate them by swapping them, which is called why it's called site swap. So I can give you a quick little proof of it.
Oh yeah.
So
Let's.
if you have some kind of pattern and these are like the numbers and you go up to some like AI plus one and so on, then what we know, if this is valid, then we know that AI plus, I should really start A0 actually.
Fine.
AI plus I is not equal to AI plus one plus I plus one. That's just saying that they're not landing at the same time,
Yes.
which is good. What that means then is that AI, yeah, plus one. No, hold on. I've forgotten how this works. That one goes there and gets a plus one. Is that right? No, I think that's a minus one. So I think AI
Oh
minus
gosh.
one
Yeah. Okay.
plus I plus one, that's the same as that, is not equal to AI plus one plus I, right? That's quite obvious. But what we're really saying here is that then you can turn this into A0, A1 up to AI minus, wait, AI, um, well, no, that should be
I'm going to draw a diagram while you find the ice. Don't
AI
worry.
plus one.
If I'm thinking about this as one in each row and one in each column, then maybe I have a picture like this. And my rule is I have one in each row and one in each column, one throw at a time, one catch at a time. And I think you're showing me that you can swap them to instead colour in, let's not use red, instead colour in this square and this square, and I'll still have one in each row and one in each column. And now I'm going to try and label it until we find all the AIs. So this is,
Yeah.
so, oh
There's
gosh.
definitely a plus one and a minus one involved somewhere.
I and I plus one for these, and your throws are going to start off with a I plus I and a I plus one plus I plus one.
Yeah.
And your new plan is, oh yuck, your new plan is to throw
Yeah, I think this is plus
to,
one, and then this is AI minus one. Like that.
yeah, okay. So this thing here is, another way of writing it is it's AI plus one plus I, which could be at time I, you throw something this height, I plus one plus one, and this one can be written as AI minus one plus
Yeah,
I
there we
plus
go.
one. There we go. Okay,
Yeah.
I agree, I think. So at time I plus one, to get to the green square, you throw AI minus one. So it swaps them, and also there's an out by one, add one minus one.
Yeah.
So allow for the passage of time to correct the fact that you're planning to do this throw a beat earlier or a beat later, respectively.
Yeah.
We got there. I see. So that's good. That means I can take like normal 3-ball juggling and do a site swap to add one, subtract one,
Mm.
and I can kind of keep doing that, right?
Yeah. So you can do that on all of like pairs of them, and you'll just get 4-2.
And sort of mangle them. And thinking about the Sudoku thing, I'm pretty sure you can generate any pattern like this by just
Yeah.
taking your initial 3 3 2 3 3 3 3, a big diagonal line, and doing these like pairwise swaps to sort of promote moves up the board or down the board. Okay, yeah, you're just swapping. You're saying when it's actually going to land, swap them and then do some sort of bubble sort if you have to or something, but it's sort them so that you're getting all the things in the right order.
Mm-hmm.
I think I've just invented 4-2 as a juggling pattern, which
I think 4-2 isn't very exciting.
So 4-2
right?
is throw height 4. I'll
Oh,
come back to this
actually,
hand.
it is quite exciting. It's hold one ball and do just two in one hand, right?
2 in one hand while you hold a separate juggling ball in your other hand. Because
Yeah.
2 in side swap just means hold that one still. Yeah, okay. I've seen better. Wait, so it's 4-0. 4-0 is a 2-ball juggling trick, right? You just juggle and you don't have anything. Don't have anything. Don't have anything in your other hand.
Mm.
Hooray! Good. Okay. We've hit 6 o'clock, so I think we should site stop. And call it a day. Any last questions from chat, or any I don't know. Sometimes I've seen people do the feather take requests from the audience. I'm not sure I'm brave enough, but last questions from here. Matty's asked about line of best fit. That gives you the original basic pattern. Yeah, sounds good, right? Or my kind of complicated diagram. It's not showing a very complicated pattern right now, but my complicated diagram, if you average it out, if you're doing a kind of repeating pattern, then you'll get some line with gradient 1 on average. The effort in chat to prove this average fact is still going.
Good.
Some line with gradient 1 because you're doing the same thing again and again. So you zoom out, you've got some block pattern that's repeating up there. Question is, how high up is it? Yeah, okay. Over a long time, it is the numbers because there's some maximum heights to your throws. So that over the time, it is the numbers permuted around. Okay, modulo right near the end. Some of them a bit out of sequence, some of them are in sequence. That's not good. It's just like there's a shift. My line of best fit is the constant that matters on the line of best fit if you're trying to work out how many juggling balls there are in a given pattern. We'll get there. Cool. Okay. As always, we'll post some further reading notes to find out more about site swap or juggling. Or we've mentioned Claude Shannon, who was the person who invented the word bit in information theory and did lots of work on entropy and things like that. Father of the information age, sometimes people say, but also really interested in juggling. So there's loads of sort of articles written by Shannon. He built a juggling robot. So maybe we'll link to that story in the further reading notes as well. Good, right, okay. I think we'll call it there. Someone says, hi, I've just joined the live stream, so perfect timing. Hi, anonymous person. You can watch it back, luckily, because they're all recorded. We've done over 100 of these, and they're all recorded and available on this YouTube channel. You're in the right place. You should see this one, or indeed any of the others. But since it's 6 o'clock, we'll say thank you very much to Elwyn for coming on the show, juggling and mathsing. We're back in 167 hours for another episode of the Oxford Online Math Club. But until then, it's goodbye from both of us.
All right.
Have a nice evening. Have a nice rest of the week. Bye.